Bismillahirrahmanirrahim. My very good friends, learners, students, peers, mentors, and supporters of the learning objective of this channel. Assalamu alaikum and very good Ramadan Kareem to all of you. As you know that we have started a new lecture series on the environmental impact assessment, which is a very important area for the policy making for the engineers, town planners, architects, policy makers, urban developers, and almost all important areas of the development sector, one way or the other way, have their decision-making process depending on the environmental impact assessment. So keeping in view the significance of the area, I choose this as a second series of lectures, our third series after the leadership, and then we had the project management. The third series of lectures is about the environmental impact assessment. And certainly, while the significance of this area, we will try to cover the important aspects of this course or this knowledge area. We discussed the fundamental definition that why the environmental impact assessment is important for the development and sustainable development. And then we also discussed the strategic environmental assessment and how the European Union started this concept that it is not only on the project based, but also in the policies, procedures, and plans of the governments and of the nations of the world. There must be environmental impact assessment, and that was termed as strategic or long-term environmental impact assessment. We also discussed the basic steps involved in the EIA process, and is just to recall that we discussed that initially we have the screening, and within the screening process we try to identify the level of environmental assessments required. Maybe the project does not need any environmental assessment, or maybe it may be only sufficient to the initial environmental assessment and or interim environmental assessment. And if the project is having some visible impacts on environment, then we may go for the formal environmental impact assessment or EIA study. And for this, we also discussed that the Environmental Protection Agency of Pakistan has specified certain schedules 1, 2, and 3, in which normally in the schedule 1 project we don't need any assessment, and in this schedule 2 we go only for the interim assessment, and then for schedule 3 projects we go for the detailed environmental impact assessment. So once the screening is done and we decide about the nature of study we need, then we go to the scoping. And the scoping, we try to do 2 fundamental things. The first is that we try to identify the environmental parameters which we would study or which will be impacted in this particular project. And then we would like to see the baseline data, that is the condition of that particular environmental parameter before the start of the project. And we also discussed that the availability of a quality and reliable baseline data is one of the fundamental challenges in the EIA studies in developing countries, and particularly in Pakistan. And that's why a bigger part of our investment in the EIA studies spent on the baseline studies. So once we decide the major environmental parameters which will be affected or impacted by the development process, then we try to predict their level of environmental impact. And while we are predicting or projecting the impact, we at the same time try to identify the various mitigations measures which we will propose to reduce our, if not altogether remove, but reduce the impact of the development on these environmental parameters. For example, if we want to study the impact of a new motorway or a new metro service on the air pollution, we would like to see the baseline data, that what is the current level of pollution in that particular area where we want to have the study, and then we would predict that how this can be used to certainly improve the. So all these, one way or the other, we are related to the impact assessments, and then we go for the mitigations measures. And once the mitigations measures are recorded, then we go to the public consultation process, and the public consultations is a rigorous process in which we try to have a series of meetings with the stakeholders to get their feedback on these various impacts and the mitigations measures which have been suggested in the project. And this public consultation, unfortunately, is not very formal. Most of the time, it is a kind of a formality in which very limited public stakeholders are involved. But anyhow, the real strength of the environmental impact assessment, study, and analysis would depend on the involvement of the stakeholders. So that is one of the most neglected part of the EIA studies. And based on the feedback from the stakeholders and the public, we develop the environmental statement or the environmental impact assessment report, EIA report. And this report has been submitted to the regulator or to the approving authority along with the project proposal. And then it is reviewed at different levels and within certain prescribed period and reviewed by the consultants and by the experts. Then finally, either the project is deferred or it is rejected, and it is recommended for redesigning or redevelopment or planning, or it may be approved. So there can be three scenarios, and once the project EIA is approved, then the project can be started. At the same time, within the EIA report, we need to have the environmental monitoring and management process also, because it is part of the EIA report that a very robust monitoring and management process must be deployed in the EIA report, because in many cases, in most of the cases in developing countries, we have a very good environmental impact reports and environmental statements. But unfortunately, one way or the other way, the proper monitoring and management is not done by the clients and by the developers, and we don't get the objectives and aims which have been set for the environmental impact mitigation. So this is really very important, that once the project is approved, the EIA is approved, there must be a monitoring process and a third-party validation process through which we can ensure that the commitments which have been done in the project in terms of mitigation of the various impacts of the development on the project are properly monitored. The World Bank has got a very strong monitoring process, and they, in many cases, they have their own consultants, and they visit the projects, and even the payment of the contractor or the installments of the projects are not released unless the monitoring is not completed. So this is really very important that we should be very careful about the monitoring process. Now, today, a very important next step is that how would we predict the impacts? There are different methods, and there are different tools and techniques. So we will discuss briefly today the different types of methods and how these methods are used in the impact assessment with some examples. So the environmental impact methods or environmental assessment methods basically are by the mechanism by which the information is collected and organized, evaluated, and presented. So we have different types of methods for the data collection and data evaluation and data presentation. And the techniques are basically the various techniques which we use to predict the environmental parameters. This may involve, for example, the mathematical modeling, the simulation modeling with the help of modern computing, and maybe some kind of sensor, artificial intelligence, machine learning, and things like that, which are coming now very commonly used tools in the prediction and projections. We can use the GIS techniques and so on. Now, the purpose of the methods is mainly to collect the data, the main environmental issues and aspects, agree the relative significance of the environmental aspects, assess the environmental performance of the proposed scheme against the significant aspects, identify significant positive and negative impacts during the project and after the project. And certainly, we would also need to have the baseline data available while we are doing this impacts analysis. Evaluate the overall environmental impacts of the scheme to enable comparison between alternatives. So if we have more than one alternative for a particular project, then based on the environmental impacts, we can compare the different projects, and for that we use different methods. Then facilitate an inclusive approach with the project stakeholders. So when we are collecting the data while using the different methods for the impact assessment, we involve certainly the stakeholders, the project proponents, the community in the data collection also sometimes, so that they have very good coordination with the project teams. The baseline study, we discussed this last time, that when we are going to predict the environmental impact of the significant environmental parameters which we have identified in the scoping process, we would need the current available baseline data about the existing physical, biological, and social environment. So this is really very important. For example, what is the baseline conditions? And normally it should be done before the project, and once the scoping decides the various parameters, then definitely we go to identify the various baselines and help in defining the impact reduction. Certainly, if we don't have the current state of the environmental parameters, for example, the current state of the air pollution in a particular area, then certainly it would be difficult for us to predict the future scenario after the completion of a specific project in terms of the environmental pollution. So this is really very important, that we should have a very well reliable and very appropriate and relevant baseline data. The baseline data involves extensive field studies, and we discussed last day that one of the basic impediment to the quality EIA in the developing countries is the non-availability of the reliable and timely data. And that's why a bigger part of almost 70 to 80% of the budget which we assign for the EIA study is spent on the baseline data collection. Then from large part of the EIA cost, we discussed that it form a larger part of the EIA cost, and may involve extensive primary data. So the actual field data normally is required because you don't have much available data about the baseline. And this primary data then later on also help in the project execution. And existing authenticated secondary data may be also useful. If you have a very reliable secondary data which has been already collected and has been published or not published, but if this data is reliable, then certain, again, that is not only reliable but also relevant and current, then certainly we can use that, but if this confidence is available. So this is one of the issue with the baseline. By the time if the system has been somewhat choked, but let us how how soon it is going to respond. We discussed last time that the baseline is one of the fundamental impediment in the quality EIA statement, EIA study, because in most of the cases we don't have the present available data, and that is something where the strength of the EIA report is also affected. So anyhow. Okay, sorry, there was some distortion, but certainly I think it has been fixed now, and yes, we will start again from the baseline date. We discussed that the baseline is one of the biggest challenge to have a reliable baseline. The yes, another that we have different kinds of methods for collecting the data. The most common and easiest way is the checklist methods. And the checklist methods, we have the standardized list of impacts, and for each project, we try to see the existence of these impacts uh, and their severity sometime. In most of the common checklists, we just have take our checklist in which we try to identify the impacts, but sometimes even the parameter can also be given some quantified value. So the checklists are standard list of the type of impacts which are associated with a particular type of a project. Checklist method are primarily for organizing information and ensuring that no potential impact is overlooked. So it is one of the easiest and sometimes comprehensive also, in which we give the large list of impacts, and then we see that the experts are analyzing the various projects under these checklists. They are more formalized version of the ad hoc approaches in that a specific area of impacts are listed and instructions are supplied for impact identification and evaluation. So it is most of the time very easy for the use of field workers. They are trained about that, and then they go to the site and collect the data. The general types are the most common one is simple checklist, in which we have the environmental parameters, and we will discuss in the examples, and then we give the guidelines about their measurement, The second is descriptive, that apart from identification of environmental parameters, we also give them the description of the impact. And then the third one is scaling. Scaling is kind of more appropriate, in which we try to see that not only the impacts are listed, but also their ranking in terms of mild, severe, or insignificant is also done. So this is kind of a checklist, but at the same time, some values also assigned to the impact. And then we have the scaling, which is more comprehensive in the sense that we not only give the value to the impact, but at the same time, we give them the weightage. So this is a kind of a weighted scale in which every parameter is given certain scale, and then every this is then finally weighted to see, because some of the impacts may be very important, and some may be moderately important, and some may be least important. So based on the scaling data, we then can multiply this with some weighted score, weight assign, and we can determine the weighted score. So this is additional information for the subjective evaluation of each parameter with respect to all the other parameters. This is a kind of very simple kind of checklist, which has been developed by one of the projects in, I think, Taiwan, Usai Thale Noi Road. And this was developed in 1980 by the National Environmental Board. And if you see, we on the left, we are given all the expected impact in the project, and then we can see that there are two major parts, that the likely impacts may be adverse and may be beneficial. And then we are further given the information that, for example, if in the impact, ST means that it is short term, LT is long term, R is reversible, IR is irreversible, and L stands for example, local, and W stands for wider or regional. So this is just not only showing us the existence of an impact, but at the same time, the nature of the impact can also be judged by this checklist. On the right side, we can have some beneficial impacts also, which can be the opportunities for any new development. So you see that for every impact, for example, if we go to fisheries, the impact is long-term, it is irreversible, and it is localized in nature. If we go to the impact on the surface water quality, for example, due to this road project, it will have a long-term impact, and it will be irreversible, and it will cover the wider area in terms of the extent or the spatial impact, of a spatial extent of the impact. So this is a very, very well developed checklist, very simple at the same time, and it gives a very good picture of the project and the existence of various impacts which can be anticipated with the project. Why we are using the checklist? Because they are useful in summarizing the information which are accessible to specialists from other fields and to the decision makers who may have a limited amount of technical knowledge. Secondly, the scaling checklist provide a preliminary level of analysis. We may sometimes not be very conversant with the impacts, but certainly the preliminary data is provided for detailed analysis. And if vetted, it will also provide information of the ecosystem functions. Problem with the checklist that they are too general, are incomplete, are very generalistic, and the detailed information cannot be extracted from the checklist. They do not illustrate interaction between effects. They normally, the checklist evaluate the various impacts exclusively, mutually exclusively, and certainly, but the environmental impacts are very closely connected. They are not exclusive. So certainly, the checklist does not give an interaction between these different impacts, or the correlation between these different impacts. and then the number of categories to be reviewed can be immense. Thus, it could distract the data collector or the assessor, the impact assessor, from the significant impact. So we could see in the last checklist that there are a number of impacts, and we may not be focusing on the very significant, and a lot of time may be wasted in the collection of data about the insignificant parameters. So this is one of the problems, some of the problems with the use of checklist. This is another very simple checklist in which we, for example, the assessment, the effectiveness of the criteria, cost and time, impact identification, impact measurement. So this just gives you very simple answers. For example, satisfied, P is partially satisfied, and N is not satisfied. So this is another checklist which is being used for the project selection. Sometimes we can give the scales, EIA methods, and the normal scale we are using. This is just the scale we use in the other data collection. In any statistical data collection, we have 4 types of very commonly used scales. The nominal, which is by name, the ordinal is by rank, and the interval is by a certain range, and the ratio is by the absolute value. So these are different scales which we are normally using in the statistics for the collection of data. I'll not go into the detail because this is a separate area where you normally have a lot of knowledge, but certainly we have to decide the scales which are to be used in the data collection for the problem of interaction is somehow solved by using the matrices in which we are using somehow the relationship between the various impacts. For example, they identify the interactions between various project actions and environmental parameters and components. They incorporate a list of project activities with a checklist of environmental components that might be affected by these activities. A matrix of potential interaction is produced by combining these two lists, placing one on the vertical axis, other on the horizontal. So this is normally the matrix method, that we have the horizontal and vertical levels, and we will discuss this in the later example. One of the earliest matrices was developed by Leopold in 1971, and it is very famous in the environmental data collection, the Leopold matrix, and it is variant. The columns of the matrix correspond to the project actions, for example, the flow alteration, while the rows represent the environmental condition, for example, water temperature and others. The impact associated with the action columns and the environmental condition row is described in terms of their magnitude. The simple matrices are very useful early in the EIA process for scoping and assessment, and for identifying the area that required further research, and for identifying the interactions between project activities and specific environmental components. So this is a bit, not a bit, but certainly more informative and more quantifiable to some extent than the checklist. But so this is that they provide information both for horizontal and vertical. The cell of the matrix are filled in using subjective and expert judgment. Again, this is one of the shortcomings, that there might be some bias from individual to individual. But anyhow, this is a bit better than the checklist. There are two general types of matrices: the simple interaction matrix and significance or importance related matrices. These are further divided into different weighted matrices and others, but we will not discuss those in detail. The simple matrix method simply identify the potential for interaction. Significance or importance rated methods require either more extensive databases or more experience to prepare. Value assigned to each cell in the matrix are based on the score assigned rating, not on measurement and experimentation. So this is normally, again, very subjective and based on the expertise of the data collection or the experts who are going to collect the data. For example, the significance or importance of an impact may be categorized as no impact, insignificant impact, significant impact, or uncertain, and so on. Or it may be assigned the numerical value from 0, having no impact, and the 10 maximum impact, or maybe 5 maximum impact. So this is the simple environmental matrix for the pulp mill project, and this you can see that on the vertical we have the environmental components, and on the horizontal we have the different phases in the project. For example, the plant construction, farming of canna, use of pesticide, transport of raw material. So the entire life cycle of the paper production, the pulp mill, the paper production has been given, and then under each phase of the project, then we try to check the various environmental components which can be expected in these projects. We discussed that the most earliest and comprehensive matrix was used by Leopold, and it is still used very commonly in the environmental studies, which has got 88 environmental components, and these components for each project, then we assess the different levels of these components. So each action and its potential for impacting each environmental item is considered. The magnitude of the interaction, that is extensiveness or scale, is described by assessing a value ranging from 1 for small magnitude to 10 for large magnitude. So this assessment of numerical values based on the evaluation of available facts and data. Similarly, the scale of importance also ranges from 1 to low interaction to 10 very important interaction. Assignment of numerical value or importance is based on the subjective judgment of the interdisciplinary team working on the EIA study, and that is the most difficult and important part of the data collection. The matrix approach is reasonably flexible. The total number of the specified actions and environmental items may increase or decrease depending on the nature of the scope of the study and technical specific keywords for which the environmental impact study is undertaken. So we may not be going for all the 88 environmental components, but certainly it would depend on the project and the expertise available for the interdisciplinary team. Technically, the Leopold Matrix approach is a gross screening technique to identify impacts. Summing the rows and columns are then designated to having interaction can provide a deeper insight and aid further interpretation of the impacts. The matrix can also be applied to identify impacts during the various parts of the entire project cycle, construction, operations, and even dismantling. This is certainly not very visible, but this gives us the range of different environmental impacts in one of the project, which is so this is in Leopold Matrix, and we can see that, for example, a modification of regime. This is one area in which we can have the given impacts like exotic fauna, biological controls, and all these. And similarly, the category of impact. And then, so you can see this is a very exhaustive list in which we can see a different kind of impacts. It's almost 88 impacts have been identified in this comprehensive scale, comprehensive method. And we will see that under each category of major actions, we have some impacts, and these impacts have been assessed based on the project. But still, one of the fundamental problem with the matrices is that it does not provide a very deeper interaction. So then we go for the next data collection method, which is called networks. But again, this is very complex, and at the same time, it requires a lot of expertise in which we not only assess the primary relationship or interaction, but we also go for the secondary, tertiary, and higher order impacts. For example, if there is any contamination of the groundwater or the surface water, then we can have immediately the first impact is that we can have some waterborne diseases in that area. Now, this waterborne diseases can, in the longer run, lead to many health problems and some genetic changes, and maybe in the long term, it can lead to some permanent distortion in the human beings, permanent diseases like cancers or carcinomic development and things like that. So we go to the a deeper level of interactions between the environmental impacts, that not only the immediate impact is assessed, but also the secondary, tertiary, and tertiary level. Development network, a series of questions related to each project. This is just like the decision tree, which we are using in the decision sciences and the decision making, that we identify the various causes, and for each cause, then we also try to identify the sub-cause, and we keep on opening the trees. And then same is the case with the network assessment or analysis, that we try to identify the series of questions which are related to each project activity, such as what are the primary impacts area, the primary impacts within these areas, the secondary impacts of these areas, and the tertiary, and so on. In developing a network diagram, the first step is to identify the first order changes or impacts to the environment. And that is really very important, because if we couldn't identify the first level or primary impacts, then definitely we will not be able to go to identify the secondary and tertiary level impacts. The secondary changes in other environmental components that will result from the first order changes are then identified, and in third order changes resulting from secondary changes this process is continued until the network diagram is completed to the practitioner's satisfaction. So it would depend on the nature of the study and the TOR of the study, the level of our impact assessment in terms of its primary, secondary, tertiary, and even higher order impacts can be also identified with the help of the matrices. The underlying relationship between the environmental components that produce higher order changes that are often overlooked by simpler approaches. So we normally, in the checklist and in the matrices, we normally go for the first order, and maybe sometimes we are neglecting a very high order, very important secondary or tertiary impact of environmental impact. So that is very important, but normally this may require a high level of expertise at one side, and at the same time, we may need a lot of time for this and money. So networks or system diagrams overcome the limitation of the matrices by accommodating higher order impacts. They are also far better explicitly identifying the causal basis for the impact. So just like the decision tree, we try to also identify the cause and effect relationships. In addition, they are well suited to identify the interactions between a number of activities, components, and a single target resource. As an assessment tool, they are capable of making qualitative predictions of the cumulative impact of the number of activities on a single target resource. However, they are neither formally integrate over the spatial and temporal dimensions, nor do they integrate across target resource. So this is very important, that you cannot integrate that at one time, nor you can integrate that at one place, because the tertiary, the secondary, and tertiary level impacts may occur at different times, and it may occur at different place. So you cannot sum up these at a particular point or a particular place. However, they are neither formally, while networks and system diagram can be communicated well and they are easy to develop using expert judgment, scientific documentation of complex system diagram require a considerable amount of human and financial resources. And I just discussed that it is not very easy for the common people to administer the networks, and we would require high level of expertise and high level of resources and also time and money, so that we can develop a very relevant and very appropriate matrix network. This is just telling us the kind of decision tree for the same. We have some primary impacts, and then we have secondary impacts, and you can see that these impacts are then further opened up, and you can have a bigger list of the impacts at the primary, secondary, tertiary level. I'm sorry it's not very readable, but it can just give you the diagram that how these primary and secondary and tertiary uh, impacts are determined. This is another network of the pulp mill project we discussed for the checklist also. That, for example, the production, paper production is having the plant construction is one activity, the canop farming for the paper raw material, and then we have the operation and maintenance of the plant. Now the plant construction have a generation of dust and particulate matters. This is the first impact, and this may increase the turbidity of water in that particular area, which may be secondary. So you can see that these networks are also, you have the air pollution and another impact, and this air pollution may have some other, for example, the public health problems. You can have unsuitable for vegetation and things like that. So we can determine, or we can open up this diagram further to assess the various level of networks, but certainly, as discussed in the last slide, their concentration at one point of time or at one place may not be easy, because these impacts are happening at different time and in different places. Then we have the spatially based methods, which is based on the geographic or on the territorial, and most of the, it's more like maps. If you remember, we are using the topographic maps, we are using the population maps, and then we combine all these maps to make the comprehensive map. So the overlay are the spatially based methods that we have the transparent maps, each of which represent a spatial distribution. If I take the general example of the geography maps, for example, if we have for Gilgit-Baltistan or for Islamabad, we have one is the population map, and the other one is the land zoning map, and the third one is the construction of the various infrastructure map, and the fourth one may be the location of important buildings in the city. So once we combine these overlays, we will have a comprehensive map or overlay which will describe all these features of the city. So same is the case with the overlays or spatial the based methods that we keep, and we will show the example that the spatial distribution of an environmental characteristic, for example, susceptibility of erosion, we can see that how the different parts of the city or the town are susceptible to the erosion. Information of an array of variables is collected for a standard geographical unit within the study area and recorded in a series of maps, typically one for each variable, and these maps are then overlaid. So this is just like having the different maps of the geographic characteristic of the area, and then keeping them one over the other, and then we have a comprehensive map. The resulting composite map characterizes the area, physical, social, ecological, land use, and other relevant characteristics relative to the location of the proposed developments. One way is to use before and after map to assess the visually changes, and the other way is to combine mapping with an analysis of sensitive area and ecological carrying capacity. There are some limitations. For example, the map can give a very good visually available data, but we cannot see the impacts of the causal relationship and the impact pathways. And secondly, we cannot use it for a very predictive kind of study, because if we need different kind of scenario analysis, then definitely the maps and the overlays cannot help us too much. This is just an example that if you look at this diagram, we have started from the water. The first map is for the water availability in the city. The second is the severance of. The third one is for noise. The fourth is the settlement. The fifth one is health. In the visual quality, the historic sites, in the ecological sites, and we combine at the top. You can see that there is a composite map which can show us all these attributes of the environmental parameters together. Essentially, the overlay method divides the study area into convenient geographical units based on uniformly spaced grid points. Topographic features are different land uses, field surveys, topographical land inventory maps, aerial photography, etc., are used to assemble the information related to environmental and human factors within the geographical unit. Factors are composed by assembling concerns that have a common basis, and regional maps are then drawn for each factor. Through the use of overlays, the land use possibility and engineering feasibility are visually determined and analyzed. The most recent is the Geographical Information System, and one of the very common tool in which we are using the satellite imageries now for understanding the different environmental parameters. So the overlays have been now produced through the digital and cellular and satellite communication, and we now have the Geographic Information System, which is the popular in situation where the computer technology and trained personnel are available. So now most of the common tool which we are now using for collecting the environmental data is the GIS and remote sensing, but certainly there are some limitations, and we still need to have the primary data to visit these sites. For example, currently we are assessing the impact of climate change on the glacial mass balance. So we are using the GIS maps, but at the same time we have also planned to go to the site, and we should also have ground truth survey, which is really very important in case of such kind of data. So we cannot only rely on the GIS data, which is the imageries from the satellites, though the high level resolutions data are now available to the extent of 5 meters, but 5 or 10 meters, but certainly it also have certain limitations that still you have to cross-verify such kind of data to the really ground truth survey. Its applications are limited only by the quantity, quality, and coverage of the data that are fed into the system. Some of the standard GIS applications are integration maps made of different scales. GIS applications are integrating maps which are overlaying different types of maps and identify required area within a given distance from a road. For instance, by overlaying maps of the vegetation and soil, a new map on land suitability can be generated, and the impact of proposed project can be studied. So this we are normally using for the land use planning, for the urban planning, for zoning, and certainly we can use the layout and the placement of buildings and facilities. The farm to market transport economics can be considered in determining the planting of specific area. This is an example that how the planting can be in a commercial area planned based on the GIS studies. Sometimes we exercise the rapid assessment procedures, which are again very quick in use, but there might be some problems with the accuracy and relevance. And these are, for example, you can see in the figure, I'm sorry it's not very easily available, but these are showing some of the factors which are studied. The rapid assessment procedure may be used to assess the environmental impacts of development. The use of waste load factors enable prediction of the approximate pollutants generated by the new development project. This is a conjunction with the knowledge about existing pollutant concentration allows a preliminary assessment of this. So we can use a different kind of models and different kind of scales, and maybe some parametric analysis already provided. On the local basis, rapid assessment studies can provide the following contribution: to define the high priority control actions, organize the effective detailed resource survey programs, organize the appropriate environmental monitoring, assess and evaluate the impact of the proposed pollution, assess impacts of new industrial developments, and help site selection. So these are not required in very details, and in most of the cases where we don't have too many environmental impacts, we can apply the rapid assessment methods. So these are some of the references. The reader can further study these references if they want. I'm sorry, the references are a bit older because this lecture is not very current, but certainly the major literature would remain the same. We can have some new papers related to the modern tools of the GIS and remote sensing, but certainly the basic philosophy is more or less the same. So thank you very much for today. We discussed the methods which are used to collect the data and assess the impacts of various parameters, environmental parameters. So thank you very much, and I pray from Allah subhanahu wa ta'ala that may Allah subhanahu wa ta'ala bless us all with peace, with good health, and may the world is once again normal and the people are back to the work, and we have a very safe and healthy life ahead. Thank you very much.